one curve is like this, x divided by under the root x square plus 1 and another curve is y equals to x raised to the power 4 minus x. And the question is same, only these two functions are given to you but no boundary. So I told you one method is that we can equate these two equations and find the values of x. Now in this case, if I want to do this, that if I want to equate both of them, this y and this y, if I equate them like this now this is not simple. If you do any kind of simplifications, it will not work because this is x raised to the power 4. And to find the root of x, can you tell me what method we know to find the root of x if an algebraic equation have power greater than 3? Two names. One name, a guy Newton, very famous. Another name, a guy Rasool, very famous. When we combine them, it becomes Newton, Rasool, and we can add the word method. Do you know this method? Don't disappoint me by telling that you don't know this method. We have wasted 2 weeks on this method. Okay, forget about Rasool. Remember this method?
Yes, we did Newton's method.
It was actually, I told you, the other name of this method is Newton-Raphson method.
Okay.
And that method was what? This method was giving us, if somewhere here we have a root, the value of x, any value, say x equals to a. We tried to approach this x from the right or from the left. And we tried to find this value. We tried from here, then here, then here, then here, and we were trying to approach here. We never go to here, but we tried to move closer. That was the Newton-Raphson method. Anyway, it has nothing to do with that video. My question was started from here, that if we have two functions like this, and the questioner, the examiner, he has not given us the boundary points, the limit points a, b. He didn't give us. I told you that we can find the limit points by equating both of them, and when we equate both of them, we can solve them simultaneously and then put them equal to 0, like shifting this thing on the left, it becomes minus x4 plus x equals to 0. Now this is an equation involving a variable x, but there is a power of x raised to the, which is raising to 4, and we up till now we have no direct method to do this unless if we use the Newton-Raphson method, and that is a very complicated procedure to find the root of an equation. So we know that how to find the root of such an equation, but it is very time consuming to apply the Newton-Raphson method here to find the root and then talk about the limits of this function. Instead of applying the Raphson method or Newton method here, the other technique is you can draw these two functions. And if you draw these two functions, one curve, and I told you in the previous session how to draw a function. Start with the value of x equals to 0 and get the points. X equals to 0 will give you y equals to what? That will be the first point, 0, 0, 1, 1, 2, 2. And you place them, connect them together, that is your curve for one function. Similarly, you can do this for the second function and you can draw the curves. Now, when for the first function, you try to draw the curve, suppose it goes like this. It will go like this if you try to draw them one by one. I don't have time to do that. you know how to do. And this will be the curve wherever it is going, but this is the curve for this function under the root x square plus 1. And the second one is going like this. And this is the curve for this function, x raised to the power 4 minus x. Now, my point is that, okay, I know this is the above curve and this is the below curve. Means this is the top curve, yt, and this is the bottom yb. So that is one thing. Either they will tell you in the question, or you can figure out here. You can see this one is yt and this one is yb. So this is one question, but the big question is still unanswered, that what is the value of a, what is the value of b? I don't know. And I told you that if you are not given the value of a and b, then the first two consecutive intersection points are enough, and you have to find an area in between that. Now, I know this intersection point, but I don't know what is the value on the x and y. So if I try to move on the x-axis using any kind of my how to say the ruler, I can figure out what is this value, and corresponding to this, for this function, this value is something like 1.18 for this function. And of course they are intersecting at the origin, so the first intersection point is at the origin 0 0, and the second intersection point is corresponding to this value of x somewhere here. I am not interested into the value of y, I am only interested into the value of, say this is y1, whatever this value is, this will be placed here. My concern is I have to determine this region A, which is 0, and B, which is 1.18. Once I got these two numbers, my data is complete. Now I can apply the area under the curve formula, and that formula says the area under the curve is from 0 to 1.18. F of x means the upper curve, that is x divided by x square plus 1 square root minus the lower curve, which is x4 plus x into the dx. Now, Josefa said that if we have integral like this, f of x minus g of x dx, can we solve them separately one by one? So that thing applies here. You can solve them separately one by one, shift the integral for the first part and shift the integral for the second part. If you do that, this is, then if you separate this minus, then this is inside is minus, because this function is this. Now you have two integrals, and suppose this is integral 1 and in between there is a minus, and this is integral 2. So I have to solve integral 1, I have to solve integral 2. For the integral 1, can you please help me to solve the integral 1? The integral 1 is this portion. Integral from 0 to 1.18 x divided by x square plus 1 dx. Now the power rule of integration cannot be applied here. What other technique we know? If you have x and dx, then the rule says it should be xn plus 1 over n plus 1. This is the power rule of integration.
Yeah.
But that power rule cannot be applied directly here, because something is problematic downstairs. We know this was the first technique. After that, we knew another technique. What was that?
Substitution.
Substitution rule. You know that you will make this guy as a substitution. Let me say this whole thing is equal to u, x square plus 1. Then what will be the derivative of u? When we talk about x, then we talk about the derivative of x also. So if I am going to shift these whole variables into u, then I will need the derivative of u also because of this integral. Whenever you write integral, you need the function and you also need the derivative of the variable which is involved in the function. So if I am going to shift this function to u, then I will also need a derivative of that variable u. So if this is the variable, then what will be the derivative? Apply the derivative on it. When we apply the derivative, left side becomes du, right side becomes 2x raised to the power 2 minus 1, that is 1, into a simple dx, plus the derivative of 1 is 0. So this will be the du, and this is the new variable u. Now if I make these substitutions here, for simplicity, you can see you have this guy, x dx. It means you can have these two below here. So now you can replace this quantity with this quantity and this quantity with this number. So the thing, you have shifted the variable from x to u. Then these values were fixed for the variable x. When you are shifting the variable from x to u, it means whatever is associated with the x, you have to shift it to associated with u. And how to shift? Use this equation. Now, when I have u is equal to x square plus 1, the two limit points are 0 and 1.18, and if I have these points for the x, then I also need these 2 points for the u. I don't care what is happening in between, I don't need that. I only need a and b for the whole integral. So when for x a is equal to 0, I can find the value of u, because u is equal to the value of x square plus 1. So u will be at x equal to 0. This function is what? Okay, let me give you one more thing. What is the substitution u actually? This u is actually u of x, and this is equal to x square plus 1. Means your function u is dependent on the value of x. Whatever the value of x will be, that will change the value of u. Similarly, when you say your function y is equal to f of x, it means your function y or your function f, they are dependent on x, and when you write x square plus 1, it means the value of y will change when you will change the value of x. If x is equal to 0, then the value of y will be 1. Put the value 0. When x is equal to 10, the value of y will be 101. So what is happening? When you change the value of x, the value of y is changing. Similar, that is the same case here. We have shifted from x to u, but u is very much dependent on the value of x. Now when x is equal to 0, the value of u means u at 0 will be 0 plus 1, 1. It means when x is 0, the corresponding value of u is 1. So this guy will change from 0 to 1. Because this 1 was for 0, was for x. And when I am going to remove this x and replace it with u, then this number will also change like this. And the upper bound is, limit is 1.18. When value of x is 1.18, the corresponding value of u will be put this value into this equation. It will be the square of this plus 1, and it will be, you can do the calculation, it will be 2.39. Put this value in the here, take the square plus 1, and the answer will be this. So the new units are now these new limit points. First limit point, when x was 0, the corresponding u at 0 of x is 1. When x is 1.18, the corresponding value of u is 2.39. Okay, I got the limit points. Now these two and these two have the same meaning, but these two numbers are for the u and these two numbers for x. When you will talk in terms of x, you will talk about these two numbers. When you talk in terms of u, you will talk about these two numbers. And now I have, since I have changed the limits, now I nowhere here I am not allowed to involve the x. I will have to write anything in terms of u. And what will be that thing? That thing will be decided from this relationship. Look, x dx, they are multiplied together and I have it here. So I can replace x dx for whatever the value in terms of u. So it becomes du divided by 2. So this guy is replaced with this. Now this is left over. Under the root, that is fine. Under the root is an operator. It can operate on anything. It can operate on t, x, u, p, z. And inside the under root, x square plus 1, and I have already told that x square plus 1 will always be considered as u. So inside the under root, it is no. Now this is a simple integral calculated for the whole area. The first part, the answer of this whole part is 0.545 minus, now I need the answer for this, and this is very simple integral. When you apply the integral on it, it becomes x raised to the power 5 by 5 minus x square by 2 under the limits 0 to 1.18.